Okay, hello again to this presentation. My name is Roland and I'm happy to present you the topic for today. This is Couchdb for fabric developers. And first, I would like to give you a short overview of this topic. So as a first step, we have to understand what is a state database. And in Fabric, as many of you know, there are two types of state databases, and but they are different, and we will look into both, and then we will see why we can use the first one and why we can use the second one. Then by default, Couchdb is not enabled, so we have to enable this. And we will do this from a developer perspective. So we work in the developer dev mode. So, and I will show you how we can extend the existing Docker Composer file for the Couchdb settings. And then, of course, we need a chain code. So I will develop a small chain code with some data item, and we will see how we can make some queries, some functions where we can query some specific elements from the chain code. And I will have also some examples where we can see how we can make ad hoc queries and so on. So that's just a little bit the hands-on tile here on this part. And one important part is also when we're talking about Couchdb. Couchdb is something which is called a NoSQL database and is organized in JSON documents. And to be efficient in any database, we need indexes. And that's the same also in Couchdb. And we will see how we can use an index, how we can deploy this index, and yeah. So indexes are important, and I will show you two kinds of indexes so that we see for what is an index good and how we will use it. And then we will do some example queries with the CLI because this is from the developer dev mode, and with this we can try and play and see how this works. Here you can find in my presentation references for the relevant topics here, which I am going to show you. So what is a state database? So when it comes to Hyperledger Fabric, we know that's a blockchain, and the blockchain has a ledger. So, but the ledger is, I think, for my understanding, that's a term, and this term need to be a little bit more explained. And in this sense, when we have a blockchain, as we can see here in the picture, we have blocks and we have transactions into these blocks. When we see here P1, P2, P3, T1, T2, and so on. So when we look at the default configuration, I think it's a new block is created in 2 seconds. So that means that when we have a normal usage, that we will have one transaction, one block in this configuration. And that's maybe the history. So that's the history from all transactions from an asset. And that's an important part, that we know what we are going to store. So we store an asset, and an asset have a state, and the state can have multiple versions. And these versions, and the change of this version is called a transaction. And these transactions are stored into the blockchain. And that could be huge. And for this, in Fabric, we have a mechanism that is called a state database. So the state database are also called the world state. This is the last state of an asset. And this is typically done in something is called LabelDB. That's the default state database. That's a simple database. But we cannot do anything with this kind of database. But it has, of course, his reason for existing, but it is limited in some points. And for this, to have a little bit more functionality, there is a second database which you can use, and this is Couchdb. Couchdb is, as I have mentioned, a NoSQL database. That means that there is no SQL involved. So this databases is something like MongoDB or Couchdb. These are JSON organized databases, and Couchdb is one of this example. And you can take one state database if you want, and this is depends maybe on your use case, and to know which database you should take, we have to know what is the functionality from each database, so then we can decide in a correct way which we will going to use. So, but the important part here is if LevelDB or Couchdb, so the world state, this is a term we have to know, and this is always the latest or the current representation of an asset with its latest state. And this is called also the world state. And in Fabric, we can have two types. As I have said, we have LevelDB and we have Couchdb. And LevelDB is a key value store. So we can only store in this kind of database, we can only store a key and a value. And the value cannot be queried. So that's an tight array, and we can only query the key. So this is the limitation of this. And Couchdb goes a step further. So that's a JSON documents which are stored. JSON stands for JavaScript Object Notation, and it's a broad standard for a lot of things, as you know, maybe. And with this, we can have full query support on key and values. So when we design a data model for an item, then we can have properties in this item, and then we can make a query on a specific item, on the maybe color and the value and age and date or whatever. And so the main difference between these both databases is that we can, in the LevelDB, we can only query the keys. And in Couchdb, we can query also the value. And the good thing is that we can query everything what Couchdb can. So that's a very interesting part. So we have to know a little bit about Couchdb and how to use it and how to find and index documents. All this topic is related to Couchdb and is not something which is provided from Fabric. So that's a plug-in, I think so. And with this, we can look in the Couchdb documentation and we can see how we can query something, how we can set an index and so on. So that's the main difference. And one interesting part or one important part, I think, is when we start a network, then we have to decide which state database we will use. So when we use LevelDB, we cannot switch later to Couchdb. So when we start a network, then we have to, or when we start the BIA in a special, then we have to decide which database we have to use, LevelDB or Couchdb. So that's an information which I found in the documentation. So, and Couchdb is not by default enabled. So we have to import it, or we have to use a service in our Docker Compose file. And this is something like this. So this is an example where you can find in the Docker, in the Fabric samples. And when we see here, we have a container name, and we have here the image name for the Couchdb. So, and one important, so this is really an important part, that we have here a user and a password for the environment. So when we use Couchdb, then we will use also per default an web UI, and this web UI has a login or no login. And when you don't set a username and a password, then you will have no login, and your administration tool is open to the world when you use a public VPS like me. Then everybody can change your values in your database. So that's really important to recommend that you have to set a Couchdb user and you have to set a password for this Couchdb container. And then you have a peer, and every peer needs a Couchdb. So we have to bind the peer to a corresponding Couchdb container. And this is done to two environment variables, which you can see here. And so here you can see the first variable defines that we will use Couchdb, and the second variable defines which container service, the container name Couchdb, and the corresponding port here is bind to this peer. And to communicate with this, we have also to say here the environment variables for username and password. So that's the same here. And yeah, so that's the only thing we have to do, that we can bind a peer to a corresponding Couchdb container. And when we use this from a developer perspective and we use the Docker dev mode, then in the default is this not included. So we have to change our Docker Compose file for this and make a little bit adjustment to this to run the dev mode with the Couchdb. And we will see this a little bit later when I will show you this. So, okay. So when we start with Couchdb, so we need a chain code. So because in the chain code, we would like to query something. So we are going to use informations. We want informations from our blockchain. And for this, we have to write some queries. And in these queries, we have different ways to write this query. So in these queries, we can strictly say, okay, we will query by name, by owner, or by any property if you want. But we can also say, okay, we would like a ad hoc query, so that we will pass the query string as an argument from the Node.js application, for example, to the chain code. And so there are different possibilities to do this. But we need a chain code, which can do something like a query and different kinds. So, and another important point is that for the indexes, it's important to say that we can use also a specific index for a specific query. So, and for this, we need a chain code. So the first thing we have to say, we need a chain code to develop. In this chain code, we use Couchdb, and then we can write the queries in a way that Couchdb can be good used. So for this, I will do this with the chain code Docker dev mode. This comes with the Fabric examples, and is a good place to develop a chain code. And I will show you how we can use this. And then we can try this chain code and play with the different queries. And as I've mentioned earlier, this Foxton interface, this is a web UI when you use Couchdb. And this is something like phpMyAdmin when you come from your web developer side. So that's an administration tool to administrate Couchdb. You can do everything with this administration tool, and it comes per default. So you don't have to do anything to get this running. And when Couchdb is used, there's a specific URL. So this is the local host, and this is the board. And with this URL here, you can connect to this Couchdb. interface, and then you can use and play with it. And that is useful when you try to create some queries, when you try to play with the Couchdb selector and you are not sure if this query is working, or when you try to modify indexes, or when you try to develop an index and so on. So that's really nice tool. And we don't have to use the curl tool on the command line. So we have a little bit more user interface that we can have it a little bit more easier to develop this. So, okay. And when we need the chain code, we have to think about, okay, how is this chain code organized? And in my demo chain code, I will make a data item. So this is an fictive example. So we have some properties. We have a type, a name, a description, an owner, and the time is an updated time. And we will have here some standard functions, and we have here two special functions, and we have the blue one is the main function. And that's how your chain code in Go, when we do this in Go, is structured. And we need the main function. That's a starting point for all Go applications. Then we need the invoke function. This is the starting point for the chain code. That's something like a controller. And in this invoke function, we will have we will pass the function name which we are going to use, or the arguments which we are going to use, and then
Roland, the slide is a bit small. Can you go to presentation mode?
Yes.
To make it bigger.
So
does it work?
Okay.
Oh, takes the whole screen. So, okay.
But I will show it then later in the development part. Then you will see it also. So, but it's important. So from the developer perspective, when we develop a chain code, so we need the main function and we need the invoke function. And the invoke function, this is a little bit difficult. Maybe for me, it was difficult to understand. So when we query from the CLI, we have two possibilities to query. So we can have peer chain code query, and we can say peer chain code invoke. So these are two functions which comes from the CLI. And but to this point, I will come a little bit later. But from the development perspective, the main function is the starting point from the Go application, and the invoke function is the starting point from the Fabric application. And in this, we will pass the function name and the arguments, and then a controller, a switch or an if construct will call the corresponding functions which you have integrated in this particular chain code. So I will have an add function that we can fill the blockchain with some values. Then I would like to query by ID. That's also an interesting part, because we have to create a new ID. So the ID is mostly a string, and we have ID 1, 2, 3, but we need a unique ID. So we have to create a unique ID, and that's a program problem, I think. So, but we can use libraries to create unique IDs. So that's not a problem, but when we have it, we are going to query this key, this particular asset by ID. That is, but for this, we don't need the Couchdb. So because the key is also in the LevelDB queryable. But when it comes to the owner, so we'll say, okay, we have a string owner and a property owner, and we would like to know how many data items has this particular owner. Then here we query the value, a part of the value, and not the key. And that's the reason when we have a use case like this, then Couchdb has to come in. And you can do this with every property here, but you can do also make something is called an ad hoc query. So in an ad hoc query, we pass the query string, which we're going to use, to the function. And when we saw query by owner, we pass the owner, and the query string is built in the chain code, in the chain code function. So these are two differences. So with this, you have more control, it's more secure, and you can say, okay, you pass only a string. The string stands for an owner, and you query the owner property from the data item. And with the ad hoc query, so you give the client side more rights, more possibilities to query something. And yeah, that depends on your business needs and how you can make it secure or less secure or more secure. And then in this way, you can write different functions. And this is the green ones and these orange ones. These two standard functions, which I have found also in the Fabric examples. And this is get query result for query string. This is one query, one function, and then a function which constructs the output. So the result, what we are going to use from the Node.js perspective is a JSON document. So the JSON, the Node.js developer, they want a JSON document back and do whatever with this information. And from the blockchain, we always have bytes. So, and we have to convert these bytes to the JSON format. And these are two standard functions which we can use for all these query functions. And how this works, I will show you a little bit later. So this is only the short diagram how the chain code is organized now. And okay, presentation mode. So, and then one important part are these indexes. So what is an index? An index is the same as in every database. So the index is only a thing that makes the database more efficient and faster to query. And the index comes from the Couchdb side. So the rules and everything we have to know about the indexes, we have to look in the Couchdb documentation. And that's the one side. The second side is how we can create such an index. And this is the Fabric side. So in our chain code folder, when we have here the chain code source file with the Go extension, and here later the builded Go file, then we need, when we install this chain code and instantiate this chain code, and we would like to use some indexes here, then we have to make this folder structure. So meta-inf, statedb, couchdb, and indexes. So this is a defined structure which Fabric needs. And in this indexes, we can create a JSON file. And in this JSON file, we are going to describe the index. And we can have one index, and we can have multiple index. So, but one important point is one index file here has one index. So when we have two, like here in this example, we will have also two index files here. Okay, but how many indexes you will use or you can use, this depends on your business application and depends on the same rules as you use Couchdb in another application. So that's the same. You can have two match indexes, but you can have two less indexes. So that's not a Fabric thing, I think, but it's a database thing, which we have to be in mind. And to create such an index, that's a simple JSON file, but there must be some required fields in. So the JSON document is structured like this one. So we have fields. These are the property names which are will have the index. Then we will have a name here and a type. So the type is I think there is only one type, that's JSON for the moment. And the name is the name. So we can use, when we will make a query, then we can say, okay, we make this query and we will use this index. So there is a property is called use index, and then then we need a name, and this is the name. So it's good to say to set a name for this, but these are required, I think so. So we have to set this one, and then we have one property that's option. That's an option. So this is the design document. So for an index, but I think that comes from the Couchdb side. So you can call this, you can set this DD doc. This is a design document. And in this design document, you have to give them a name, and Couchdb created a design document for this. And this is also important. So when we try to update your index, so from time to time, maybe you have to update this index when you need a different index or something like or other things happen. So when you need to update this index, then you have to use the document design document. You need this document design document. So, but you can also delete an index. So, but I think Couchdb has not a tooling for the deleting of an index. So you have to do this with the curl command, or you have to do this with the Foxton UI with the administration tool, which you will show a little bit later. So, and that's the
Ronald, so excuse me, I will add one thing here. Yes, we can have as many indexes as we want, but like every database, we have to be vigilant that yes, indexes help us in searching and these things, but we can't make, we should make only few indexes. If we are making too many indexes, it will make the process slow. So we have to be vigilant to make the indexes. So it means it's open, but we have to be reluctant to adding so many indexes. So just wanted to add.
I think I have mentioned this a little bit earlier. So you have to be carefully, and that's not the favorite part. So that's a part which comes to every database design. So when you set when you use too much indexes, then the overhead will too high, and then the database will not efficiently work. So that's an important point. Good that you have pointed this out again, and that's really important. So you have to think, and that's, I think from the developer side, we have to have a really good understanding what we are going to use, what we are going to build. So we have to know our use case, we have to know which query we are going to use and which information we will have, we will use from the blockchain. And so the planning from the chain code and the planning from the indexes and from the database, from the state database, is an important part in the preparation when you would like to develop a chain code, I think. And the last sentence here is also important. So a question is when this index is updated. So in the documentation, they use a word, it's called a warm update. And that means, and in the sense of Fabric, that means that when a new block is created, the indexes are committed. When a new block is committed, the indexes will be updated. So that's also an important part. How large will your block size? So, and then you will have the update process for the index. And when you will have a huge database, then you will have also maybe it takes some time. So, but that's important part, important question. When is the index updated? And the index is updated when a block is committed. So, okay. So now let's see this in action. So to do this, so what I'm going to do now is I would like to develop this chain code, which is here descripted, and I will use the developer, this chain code developer part from the Fabric samples, and yeah. So the first thing what we do is, so we have to say, okay, we need some Go dependencies. So last week, as Mushanka, so that's correct.
You can say Mool only, Mool.
So I'm not so used on your name. Sorry for this.
It's okay. It's okay.
And so we need some dependencies. And when you come completely new to, when you have a new installation from Fabric and you try to build your chain code, then you need some dependencies, some Go dependencies. And the most important Go dependencies is the Fabric dependencies, because you have to clone this GitHub repo for your Fabric version, and in this you will have the shim library, which you need for the chain code development. And in my example, I try to create a unique ID, and for this I used from a third-party library from Google, this unified user ID. And so we have to install this, we have to clone this, and that's the first part which we have to check. So for the demonstration, I use a terminal multiplexer, as I have done in the last session again. So, oops. So, and we can switch to the Visual Studio Code. And for development, I use Visual Studio Code. And in the Fabric samples, when they are installed, you will have a folder here. This is called chain code docker dev mode. So this is a folder where we can find some tooling to develop chain code, and that's the folder here. So that's the part here, and this part here is my chain code folder where some examples are put in. So, and the first thing what we are going to do is we have to look to the Docker Compose file. So how we can start this development environment. So, and in the Fabric examples, there is this folder, and there we have a Docker Compose simple YAML file, and there's everything what we need, but we have to link the peer, this one, to a Couchdb container. So that was what we have seen in the slides. So, and then we have to use here a username and the password. So, and I use the functionality from the Docker Compose file. So to don't write your credentials in the YAML file, and store the YAML file in a Git repo, for example. So to avoid this mistake, we can use these environment variables from the Docker Compose side. So this works very easy. So we can define here variables, and when we have here in the folder, we can create an .env file. So the dot is a hidden file, and in this we can define this in a key value pair mode. So the first thing is the variable, and the second part is the value. So Couchdb and password. So So that's a good way to hide your password. And then by the BR service, so we have to use these for environment variables. So we have to say the state database is Couchdb, and we will have a username and we have a password. It's the same. And this beer will use the Couchdb, the service name, it's this one, and the port. So, and that's all for this. And in my case, I have a second modification. So in the CLI container, we have to mount some points. So we have to mount the path to your shim, to your Fabric Go libraries. And we have, in my case, because I don't use the default path here, the chain code path, or the path which is this one here. So where all chain code examples from the Fabric example site lives. So this one here. But you can have it as well on any directory, but you have to link it on the same position. So, and you have to do this in the CLI container, and you have to do this in the chain code container. So the chain code container is to build your chain code and to bind to create this chain code container. So every chain code is running in a container, and Fabric, when you use it in a normal way, so Fabric starts it automatically. But when you use this dev mode, then you have to start this chain code container by hand, and this is done in the chain code container here. And yeah, and the CLI container needs as well. So, and these are the some small adjustments to this container. And then to this composer file, then we can start this, but not here. So and now the dev mode network is starting. So we can, so you see I use the terminal multiplexer Schmucks, and I have prepared 3 panels here. So in the first panel, this is the network, and in the second panel, this is the chain code container, where we will build then our chain code and bind this chain code to the chain code container. And then in the third panel, we are going to use this. This is the CLI container. And in the CLI container, we can install the chain code, instantiate the chain code, and query with the CLI commands the chain code. So that's a part of the preparation. And now we need a chain code. So when we're going to use our chain code, so we can have here this, I've prepared here a small Go file, but it's empty. And I will copy and paste the relevant aspects to the file, so that you can see what's really going on here. So the first thing is we need this main package. And then we need some dependencies to import. So, but these are, I think, basic things. So bytes is a basic one. So encoding JSON. The FMT is for the printing. So I think Yeah, and time is, we are going to use a date. So we need the time package for this to create a go date. And then we import the third-party library. And so that's the shim, which we need. And we need the peer package to develop this chain code. And the next steps are, so this is the chain code implementation struct, and then we will use our own data item. So we will have a type, a name, a description, an owner. This all are strings, and these are the corresponding JSON field names. So we have type, name, description, owner, and time. And only for the updated add property, we use the time package with the time. So, and the first part is we need the main part of every Go application. So the main function is the starting point of the node application. And so that's also, and then we need the init function. So the init function initializes the chain code. And as we have seen in the last session, Mulshankar said that we have to be really carefully what we are going to put into this init function. And because it will be, the init function is called also when we upgrade or update the chain code. And that can have can lead to some problems. So in my case, there is nothing in this init function. So there is only the return value. And then so as I said, this is the starting point of the Go application. And this is the starting point of the chain code application when we not see at the moment the init function. So for the normal use, we have this as a starting point. And in the starting point, this works like a controller of the chain code. And the first thing what we need is the function which we are going to call and the arguments. And these are delivered with this start method, get function parameters. So in this way, we have two return values. One is the function and one is the argument. And then we can have here an if construct and switch construct or what else, so that we can control which function is called when you call the invoke or the query function from the outside. And that's very simple. So we have the function name here, we have a function, and we have a return function. So, and that's basically the same for all these things. And when you call something which is not in this function list, then we will have we can call an error, and we can give here an error message return. So, but I think that's a basic structure. This is a basic structure where you can find in every example. I think most examples are structured like this one. So, and then we can implement, we need a method where we can fill in some data. And this is the add method. So I think these are all points are straightforward. So we need 5 arguments. So because we have 5 properties. So we need these properties. So, and when we don't have 5 properties, so we will quit and we will throw an error. And then we create some helper variables to have a little bit more understanding. So all arguments came in an array. So, and in the order which you are put it into the caller function. So on the first position, on the position 0, you will have the data type, then in first the data name, and so on. So that's depends on your structure, how you will do this. And then we have a date, and for the state we need the layout, and that's in the fourth parameter. And then we have to pass this, and then we have here a date object, and we can fill in this here in the date object, yes, in this point. And then we have here a data object that uses our struct, which we have defined here. So and this data item represents now the value from this item. So the value from this item, when we say, okay, we have a key, we will store a key and the value in the blockchain, and this data item is now the value. But we need the key. And for the key, I use this Google Uniform Unified ID. And then we have to pass this to a string, because the key is a string. And then, because we have to convert this to bytes. And then we have a data item as bytes, and we have a key. So, and this is the point where we say, okay, this will be stored now in the blockchain. So, and when we use level DP, then we have only the key and these bytes. So, and we cannot query these bytes because the bytes are not queryable here. But the key is the key. So the key could be a string in any format, but must unique, because when you call, when you have a bot to this key, then, and the key is an existing key, then you will have an update. So a second version of this asset, of this key. So, and that's the reason why we say, okay, we need a Couchdb. So that because we would like to query, we would like all data items from a particular data owner, for example. And that's the part where you can recognize this is the line, this is stored into the blockchain. So into the blockchain is stored a key and something which is converted to bytes, and that's it. So now we have data, and then we need some information from this blockchain. So, and the first is the function query by ID. So, and as you can see, in all query functions, you will have mostly the same structure. So we have an error variable. So we have a validation of the arguments. So when it's not simple 1 or 5, like in the other example, we throw an error. So, and then we grab this from arguments, the user ID. So this is a string. So because we deliver a string in our call, and then we have to define a query string. And here you can see a JSON formatted string, in the way how Couchdb this does. So they use the selector and selector object, and so that's a normal JSON. That's a normal JSON object, and this JSON object has an object, a selector, and this has an object with the ID and the user ID, which we are going to use. So, and the sprintf function is only a way to bind this argument to and fill it in on this string position here. Now, so, and here you can see how you can query this in the Couchdb way. So, and you need a selector and then you need a JSON object, whatever the query should like. And then you can call this get query result for query string. And these are the two functions here. These are two special functions which you can find in the also in the fabric examples. So I will copy this function in. And this function is also, I think, a standard function which we can use to query the blockchain with our query string. And then we have to decide, so is the result a single line or is it a multiple line? So is the result an array or is it an object? And for this, then to have we can, yeah, as you can see here, the get query result function pointed and result iterator. And when the result is ready, it closes this channel. And then we can construct here the output format. And to have every time the same output, there's a second function which generates the output for us. And the result is every time a key and a record. So, and the record is, in our case, is a JSON object, like we will receive it from the Couchdb database. So, and this is the kind how the output is created. And then we write this to a buffer, and this buffer is then converted to a string, and then we will have the JSON output. So these both functions, you can say these are helper functions. We are going to use in every query function to query the data and prepare the output for the delivery to our Node.js application or to any other client which is going to use the data. So this is query by owner. So now query by owner. So the second query function is query by owner. So it's basically the same as you have seen in the query by ID. The only thing is that we will have here another definition of the query string. So we have the selector and we have also the owner, but we can use also, in my case, this is a sort function from Couchdb, and we can say, okay, we are going to sort to the time, with the time, and these in a descending order. So this is the function where we say, okay, we're going to use all data items from a particular owner, and we would like this sorted by time. And here you can see the query string in the way we have to when we use Couchdb. And the other parts are the same as you have seen in the query by ID function. And when we would like to do such an ad hoc query, so you can make basically the same, and then you pass the query string directly to this get query result for query string function. And then if the query is correct, syntactically correct, then you will get an result. So, okay. So I think that's the chain code, which is here described. And when we wrap this up, so we can see that the structure of a chain code is every time the same. So we have a main function for the starting point of the Go application. Then we have the invoke function, which works as a controller. So we can pass a function and we can pass arguments to this invoke function, and then we can call functions according to the function name. And then we have something to store. So, and we store a key and we store a value. So that's the basic information. So this, and the value is always converted to bytes. So, yeah. And for the chain code here, it doesn't matter if this is a LevelDB or this is a Couchdb version. But when it comes to the query, so we have here the selector. So this only works when you use Couchdb for this. So, and that's the reason why you think about before you develop your chain code, which queries and which state database you are going to use for your business needs. So, okay, chain code is ready. And as I have mentioned, I have 2 indexes. So, and here, when we install the chain code, then we can create also the indexes. And this is done in the install process from the chain code. And for this, we need 2 JSON files in this structure. So we need a folder which is called meta-inf, StateDB, Couchdb, and indexes. And there we have to fill in these 2 indexes. So, and you see that's what we have seen in the slides. So we have fields, we have the owner, we have the time, we have a name, index owner, and we have the document design, the design document name for this index.dev, and we have the type JSON. So there's only this JSON type, I think so for the moment, and so, and these fields are, yeah, these are the column, the properties from the order, and it's the same here for the index time. So when we want an index only for the time property, then you can do it in this way. So, and that's the only thing you have to do. So, and then to switch this, so we can go back to the dev mode. So, and our dev mode is running. So now the next step is that we build our chain code. So, and if everything works correctly, we have to switch into this. So we can see Docker PS. So now you can see, you can check. So, and you see here we have an orderer, we have a peer, we have the Couchdb, yeah, we have this chain code container, and we have this CLI container. So, yeah, and now we go to this chain code container. So, and we switch into this chain code container. So now we're inside this chain code container. And because of our changing here in the Docker compose file, in the chain code, yeah. So here we have mounted my personal chain code folder to this default chain code folder here. And now we see this folder, nft1, and there we have our chain code. So that's our chain code. And we have here the folder structure for the indexes. And the next step, if everything will work, is we have to build the chain code. So this takes some seconds. And now the chain code, the Go program will build. And when this process is finished, we can bind the, so now you can see here, this is the ready to install chain code. And the next step is we have to bind this chain code to the chain code container. And this is done with this command. And now we can switch in the third panel. And the next step is that we can install and instantiate this chain code. So I think there are some problems with the, we have to use the CLI container for this. And we have to switch in this GoPub source directory. And then we can try to install this chain code. And this is done with the command be a chain code install, the path to the chain code, the name of the chain code, and the version, with version 0. So, okay. So response is payload okay. So this seems to work. The next part is to instantiate. So when you install a chain code, you have to do two things. So the first is to install it, and the second is to instantiate the chain code. And this is this part. So when we initialize the chain code. And this is the command type, be a chain code instantiate, then the name of the chain code, the version, and then some arguments, but this is for default. And then on which channel. So by default in this scenario, we have a channel, a predefined channel. The channel is called my channel. And then the chain code is instantiated. And now the next step is that we fill in some data. So I have to copy and paste this. But we can copy this here to see it a little bit better. So what we really have to see is, so be a chain code invoke. So the last slide of my presentation is the difference between the be a chain code invoke and the be a chain code query. So for me, finding a learning is that both functions go through the invoke function from the chain code. So with query, you don't query a function directly. It goes through this invoke. So that's I think an important part. This is something that was new for me. So I think that's an important part. So everything from the chain code goes through the invoke function from the chain code. But the invoke command, when you call the invoke command, this command will be sent to the orderer. When you use the query command, then you call the chain code, but this will not go to the orderer. So it is only for querying data. So, but when you call the invoke command, then it goes to the orderer and do that what the orderer should do. And when we see the command here, that's the command, that's the args. So we have, and this is with an array. So, and the arguments, and this is the point here. So this args, when we call the function get function and parameters, so yeah, we got the function, yeah, and we got the arguments. And this is here. So the first one is the function, and these starting on the second position here are the arguments. And these arguments starts with the index 0, yeah, and the first part, this is the function. So, and you have here an array, a string array. Also the date is a string array. So that's a date in the ISO time format. And these are the arguments. And this is the name of the channel. So these are the parameters. So that's an important part to see if this is new for you. That's really important that you see, okay, the function is the first argument here. And the args here, yeah, are all parameters here from the second position from this array here. Okay, so I'm going to do this. Okay, chain code successfully. So that means that we have a first transaction, we have a first block, and we have an asset stored into the blockchain, and we have only one version, and this version is displayed, it should display it in the Couchdb. And for this, so we have to look into the so this is the not the local host, so I'm using a droplet on DigitalOcean. So this is the public IP, and but the port is the same, and these and the URL is like this. And when you have set the username and the password, that's the important part here. We look to the Docker Compose file. So this one. And then you will have here a login, a username and a password. So that's important that you, when you use only this on your local machine, it doesn't matter. But when you use it in a public environment, then you have to set the username and password and to log in. And this administration tool is per default installed when you use Couchdb. And that's the same like phpMyAdmin or something like this. And you have here different databases. And for us important is the my channel. So you see this format. The prefix is my channel, yeah, and this is my chain code. So yeah, and we have 3 documents in there now. So why 3 documents? Because we have 2 indexes. We have 2 indexes here, the owner doc and the time document index. So, and we have also the design document key here now. You see design index owner doc, design index time doc. And both indexes are installed during the installation process because we have put this here in this meta information folder. And here, this document is our chain code, our first transaction. So, and you can see here, okay, this is my ID, this is the key which we have generated, yeah, in a unique way. And these are description, the name, the owner, the time, yeah, the type, so yeah, and version. So these both reference and version. So these are Couchdb related items. So, and the ID, description, name, owner, but ID is also Couchdb related, but it's the same as we have in the blockchain as a key. And now here we see these. So when we're going to fill in a little bit more data, like this. So and one more. Oops. Okay. So you see, there's a small error, but you have to be careful with the copy and paste. So this \n for new line, that's not good in this position. So now it works. So, and we see now we have seen documents here. And we can look into these documents. This is the first one. And this should be declare and so on. So now we can see here this document. And we can look here into this one query. And when you don't know how you can, how you should write this queries for MongoDB, then you can use this Mongo query editor. And you see here, that's the way how Couchdb queries do. So, and you see, and then here you can try the queries. So a good starting point for this is the Couchdb database. So, but be careful with the versions. So in Fabric 1.4, we use the version 2.3.1. So, but in Couchdb, we have different versions. So we have 3.1. I think 3.1 is the latest version. And so we have to look at the versions. So the version is, we see it in the Docker image. When we look from the Couchdb Docker image, then we see this version 2.3.1. And in this documentation, you can find everything you need to query and install. And you can also check the indexes. So there is a link manage indexes. And you see here the indexes. So, and we have 3 indexes. The first index is a special one. So that's the ID. So of course, so every database needs an index of the ID. So, but this is set by default. And these are our own indexes. And here we can see. And if you want, you can try to change these indexes or create new one indexes. And yeah, you can do this in this way. So, okay. And then let's have a look how we can query this now. So this one. So, okay. So the first query was PyID. So, okay, this is the article 4, and this is the ID from the article 4. And now we can try to query this. So, and then here you see, okay, this was the invoke function, also peer chain code invoke and peer chain code query. So, but both go through the invoke function in the chain code. And the first argument is the function, and the second are the arguments which we are going to use in our function. So there's only one, the ID, my channel. And that's a tip from my side. So when we call this, then we receive a result, something like this. So, okay. But we use the JQ tool, the JSON parser for the command line. Then we will see this. So that's really nice. So when you pipe the result of this PL chain code query to the JQ parser, and you use the dot, which represents the first item in the JSON document, then you will receive a nice output for the query. So, okay, and you see that works. So we have this ID, and we have queried this ID. So, and the second one, I will show you to see a multiple result. So this is queried by owner, and we are going to use the owner Bole, and then we should receive more than one result. And here we go. We have here more than one result. So okay, the scrolling in the Tmux terminal is a little bit different. So that's a shortcut, Control P and the key FN and the error keys. So on the Mac desktop. So, and then you can see, okay, here we have a multiple result. So we have two results. So the article 1 and the article 3. 5, so, but not 4. And you see, this works as well. But now we have created not the key, we have created a value, a property inside the value. So, and that's the difference. So when we use LabelDB, we can query this form. So we can only query the key. So, but not, yes. So, and that's the main message for this, for the difference between LabelDB and Couchdb. So, and when you have a data structure to query some specific item, you have to set a data item with the corresponding JSON types here. And then you can use Couchdb to store the world state, so the last state from this asset. So to be clear, this is an asset, this is my asset with this ID, so, and this is unique. And for this asset, I can have multiple versions, and these versions are logged as a history in the blockchain, and the last state is displayed in the state database, in LabelDB or in Couchdb. So, and one last thing from my side here is when you see this, so you have to query, you have to develop here queries, and you can test things with this. And when you find your target query, then you have to bring this in this you have to bring this in this format, something like this. So, okay, you can do it by hand. Yes, I know. But as I played around with that, I found out that we can use also the JQ parser to do that for us. So, a last example here, we have a selector. We want the owner, and the owner should be Roland Bole. And then we can use the index. So, and in the first one, query by ID, we have query by ID, and we have only the key, the value here to query this function. But we can also say, okay, we use an index. So, and then we have to give we have to point we have to give the information from the index document. And this is the index document which we have seen here. When we manage index, no, this was here, the first one. So this one, these two indexes. So you see the path, the ID, the sign index owner doc. And that's the same. So use index, this one, and the name. So these are the required parameters to, when you say, okay, I want this information, the owner, yeah, but I will use this index. So, and that's the reason why you need a name for the index and the design document. But I'm not sure if you really need this. Maybe it's enough to say the index name. But when it comes to update this document, this index, then you have to say to use the index design document. So, and to cast this, so, and for JSON, we have to cast this double quotes, that we have this structure, something like this. So. And then you can use the JQ parser. It looks like this. So to leave this session. So now. So when we copy this in, so this is, we copy this directly from the Mongo query. So, and then we can create this thing. So, but here in the terminal, it's a little bit difficult. So we can do this. So we direct this to a file. Okay. So, and then the only thing you have to do is to remove the \n on the last position here. So, yeah. So, and then you have this query. And now you can call with this. We'll fill this in here in the ad hoc query. So I hope that's correct. Yeah. So yeah, and you see, and then you can say which index should use for this particular query. And now we have used the ad hoc, the query ad hoc function. So we can now in this moment, when we will give this freedom to the Node.js developer or to the Go developer, to the client developer, yeah, then he can write a query on his own, because we query by we pass the query string directly to the get query result function here. Okay, so that leads me to the last slide here. So in the slides here, I will publish the slides later. So in the slides here, you find the way where you can, how you can start the Jcode Docker dev mode. So as I have shown it, so with by use for commands. So that's this one. So, and that's the last slide for today. So the be a Jcode command Yeah, that's maybe a lot of you know this, but for me it was a little bit difficult to understand. So my impression was the query calls directly the function in the chain code, but that isn't true. So both go through the invoke function in the controller in the chain code. So, but the difference is the invoke function calls the transaction and start the order process, and everything is needed to create a new item. And the query function queries only the peer. So when we remember the Node.js session for 2 weeks ago, then we know that in the connection profile, we can say which endorsement here we are going to query. And that's the reason, and that's the goal from the query. So that's only querying, no ordering, no transaction will be stored here. And the invoke function is the starting point where you can create a new transaction and where you can create an asset, or you can change the state of the asset. So I think that's from my side. Thank you for your time. So if you have any question, I see it, we have a little bit over time now. So you can post me your questions on the Slack channel, and I will post the slides later. And in the slides, you can find here also a link to the GitHub repo here. This is this one. So if you would like to try something out, and here you can find the chain code, which I have demonstrated. You can find here a helper markdown file, so where all the steps can be seen as additional material here. So you can try to reproduce this example and play a little bit with this example. So
please mute Vani, Kaldun. Ronald, mute them, please. Vani special. You should please mute it at least.
Okay, it's muted. I can do this. So. Okay.
Yeah, you can.
Thank
you.
Okay, so now I think that's the end of my presentation. As I said, if you have any question, please post it on the Slack channel. And for the next time, I hope I would like to say, you ask, is there anybody out there who is going to make a short presentation to display a topic for the next time? So we have a public Google Sheet where you can fill in your topic and your name, and it would be really cool if someone of you can show us a short example or something he has learned this week. And this is not a learning program from my side, so I have to say this. So, but I do that. It's very interesting to do this for me, but I'm here as well as a student and not as a teacher, so I have to say it in this clear way. So, and it would really a good way if someone of you came in next week and say, okay, this is my short presentation. I would like to show you how we can test the chain code. So that's an important part. And this series is about the certification, the developer certification. And in the developer certification, we have a list of topics from domains which should be known for the certificate. And this is in our Google Sheet file. And you can go through this Google Sheet and you can say, okay, there is a point, which is the Untitled channel-based events. So that's an interesting part for me. I would like to present this next week. And yeah, So it would be, and this is really for you, and don't be shy. Show us your knowledge, and you can have some time slot here, and you can present something, and you can ask something. So there are sometimes 10 and more, 20 people, and they can help you and so on. So please take this opportunity to show something, to learn something in this week, and next week, so maybe you have time, and then you can show us an example. For example, query transaction history. So how we can show all transactions to a given asset, for example. So that was a very super nice example, and that would be really nice if somebody can do and contribute on this series. Okay, so that's from my side, and I hope you will have a good weekend and stay safe and in this difficult time. And I hope we will see you next weekend.
Thank you, Ronald. Thank you for that much effort. Much appreciated. Thank you. And thank you everyone for joining us. And see you next week.
Thank you.
Thank you. Bye.
Bye.